So now let's take a walk through the MIPS pipeline. Let's see what all the stages do and how the instructions interact. So we're going to look at a load instruction going through the pipeline, and there are two key things that you should pay attention to. The first is what happens in each stage. That is, what is the combinational pipeline logic doing in each stage? And the second one, what is stored in each pipeline register? That is, what is the state that we bring through the pipeline? So let's go ahead and get started. Here's instruction fetch for the load. So the first part of the pipeline. So what do we do in instruction fetch? Well, we're going to calculate PC plus 4. That is, we're calculating the next PC to load. And we're going to load the instruction from the instruction memory. So what are we going to store in the pipeline register? Well, we're going to store the PC plus 4 we just calculated, and we're going to store the instruction that we just loaded. So here's a question. Why do we need the instruction in the next stage? Well, the answer is all of the above. We need the instructions RS and RT fields to figure out what registers to read in the next stage. We need the immediate value so that we can sign extend it in the next stage. And then in later stages, we need the instruction information so we know what ALU op we're going to do. We know if we should take a branch or read memory. So we're going to need all of this data later on. Now here's the ID or instruction decode stage. So what are we going to do here? Well, we're going to take the information we had before and we're going to read from the register file. So we're going to use the instruction that's waiting for us in the pipeline register, and we're going to use that to figure out what data to read from the register file. We're also going to take that instruction and calculate the sign extended immediate value. Now we've done those two things, so what are we going to have in our next pipeline register? Well, we're going to keep the PC plus 4 in the instruction because we need them later, but now we have more stuff to put in our register file. We have the two values we've read from the register file, plus we have the sign extended immediate, and we're going to use these in later stages. Now here's the execute stage. So in the execute stage, we're going to do two things. We're going to calculate the branch address, and we're going to do the ALU op. So these are going to use the inputs we have. So the branch address is calculated using the PC plus 4 and the immediate, and the ALU op is going to be calculated using the reads from the register file and or the immediate value. And what are we going to store as the result of this stage? Well, we're going to keep the instruction. We don't need PC plus 4 anymore, so we're going to keep the branch. We need the results of the ALU, that's what we've calculated. We need whether the ALU is 0, and we're going to need the results of RF2. So why do we need to keep RF2? This is the output from the second register read. Why do we need this at this point? Well, it's needed as the data for the memory. If we're doing a store, the output from RF2 is what we're going to write into the data memory. So we need to keep this in the pipeline register in case it's a store instruction. Now we're going to go to the memory stage. So in the memory stage, we're going to access the memory. And how do we do this? Well, we use the output from the ALU as the address, and if we're writing, we use RF2, and if we're reading, we just read. What's the result of this stage? Well, we're going to keep the instruction. We need the results of the memory if it's a read, and we need the results of the ALU if it wasn't a memory operation, because we need to write those back into the register file. And then finally, here's our write back stage. And what is it going to do? Well, it's going to write the results back into the register file, either from the memory or from the ALU operation, and those are going to come from our previous pipeline register. So where does the write register come from? Where are we getting the correct register ID to write into? Well, in this example here, it's coming from the IF pipeline register. That is the pipeline register right next to it. So whatever instruction is sitting in this pipeline is going to choose the write register. And this is clearly wrong. We don't want this instruction to be used. We want to use the instruction that we had in our pipeline register. So we want this instruction. We want the instruction whose data we're writing back. The blue instruction here is 4 instructions behind that instruction. This is the wrong instruction to look at. So we need to fix this. How do we fix this? Well, we're going to have to change the wiring around. So now our write register is coming directly from the instruction in our last pipeline stage instead of coming from the instruction in our first pipeline stage. So this will give us the correct write register to write into. So here's our MIPS pipeline with our 5 stages, and let's walk through again everything that's going on in the pipeline. So in the instruction fetch stage, we calculate the next PC and we load the instruction from memory. What we put in our pipeline register is that next PC and the instruction, and these are going to be used in later pipeline stages. In the instruction decode stage, we read from the register file and we sign extend the immediate field. And what are we going to store in our pipeline register? Well, the same PC plus 4 and instruction we had before, but we're also going to store the outputs from our 2 register file reads as well as the sign extended immediate, because we may need these values in later stages for the instruction. In the execute stage, we calculate the branch address using the PC plus 4 stage we have from the pipeline register and the immediate field we have from the pipeline register. We do the ALU op, and then we're going to store our results. So we're going to store the same instruction and the same register file 2 that we had in the previous stage, but we're also going to store the new branch address. We no longer need the PC plus 4 because we calculated the branch address in case we're supposed to do a branch. We're also going to store the results of the ALU computation and whether the output was 0. Then in the memory stage, we're going to access the memory, and to do this we use the address, which is directly from the ALU, from the pipeline register before us, and if we're writing data, we use this data from the RF2, which was in the previous pipeline register. Then we're going to output data from that, we're going to keep our instruction and our ALU result, and we're also going to take the data from the memory, because we need this to decide what we write back into the register file. In the write back stage, we're going to write back into the register file, but we need to remember that we need to use the write back register from the instruction in our pipeline register, not the instruction that's in the IFID pipeline register. So a question, which stage uses the sign extended results? Well, it's the EX stage that uses the sign extended results. They're computed in the ID stage and stored in the pipeline register after the ID stage, and the EX stage then uses them either for an ALU op or for part of the address calculation for a branch.